Hi, this is Miss Nowak. This video is going to briefly explain what we mean by congruent when we're talking about congruent triangles. If you'll recall from class, the word congruent means the same size and shape. We don't, for shapes, use the word equals typically because equals implies also the same location, so two equal shapes would have to be right on top of each other. Congruent just means the same size and shape. So two segments that are the same length would be called congruent segments. And we can indicate that in the diagram by drawing the same number of hash marks through them to indicate that they're the same length. It could be any number. If we put 3 hash marks on both of these, that would also mean they were congruent. For angles, a congruent angle just means it has the same degree measure. And to indicate that on a diagram, we would use a little arc like that. So since both of these have one arc through them, it means that they're congruent angles. If they don't have the same number of arcs through them, it implies they're not congruent, or that we're not sure. But if they both had 2, that would mean they're congruent. So if we're talking about congruent triangles, we're saying that the triangles are exactly the same size and shape. So you could think of this as if we cut both of these out of paper and we put them right on top of each other, they would be an exact match. They're like clones of each other, okay? Except these two, A, B, C, and D, E, F, are in different locations. But if I know that they're congruent, that implies that they have 3 pairs of congruent angles. So in these two, it would have to be the 2 largest angles, B and E, that are congruent. The pair of the 2 smallest angles are congruent. Angle C is congruent to angle F. And the pair of medium-sized angles are congruent. Angle A is congruent to angle D. If these triangles are exactly the same shape and size, then of course their sides are also the same length. So the shortest sides, A, B, and D, E, must be congruent. The longest sides, AC and DF, and the medium-sized sides, BC and EF. If I want to write that one triangle is congruent to each other, it's important to keep the corresponding angles, the pairs of angles that are congruent, in the same order. So if I want to write triangle CAB is congruent to the other one, I have to write them in the same order such that since C is congruent to F and C comes first here, I need to write F first on the other one. The medium-sized angle A is next, so I have to write the D next, and then the B goes with the E. Okay, so this is okay, but if I wrote triangle CAB was congruent to triangle EDF, that would be inaccurate. In a congruent statement, we want the congruent angles to go in the same order. This isn't the only way I could write this one. If I wanted to write triangle EDF, then I would just have to put the corresponding angles in the same order on the other side. E goes with B, D goes with A, and F goes with C. So this in the green is okay, this in the blue is okay. The one in the red is not okay because the corresponding angles don't go in the same order. Okay, so in this problem I'm assuming that these triangles are congruent because it's asking me for a congruent statement. So before we try to do anything, let's figure out which angle goes with what. Let's give the smallest angles one arc, the middle size angles two arcs, and then the largest angle, which looks slightly obtuse, three. And the congruent sides have to go in between the congruent angles. So the short side is in between the 2 hash marks and the 3 hash marks. The side in between the 1 and the 2, in between AB, has to be the same as side DE. So then the third sides, by process of elimination, are congruent. So a couple ways that we could write the congruent statement for these. Our triangle ABC is congruent to triangle EDF. The corresponding angles go in the same order. If we wanted to say CAB, then we'd have to switch the other ones around. FED. If angle C is a right angle and angle E is 25 degrees, find all other angles. Okay, so we're told angle C is a right angle. That must mean that it's 90 degrees. That's a definition of right angle. So if angle C is 90 degrees, since these are congruent triangles, angle F must also be 90 degrees. We're told angle E is 25 degrees. That must mean its corresponding angle A is also 25 degrees. And then we're not given any information about angle D or angle B. But one thing we know about triangles is that the three angles in a triangle have to add up to 180 degrees. So to find angle B, I can say, well, angle B plus the other two angles in the triangle must add up to 180. So I can solve this little equation. 25 plus 90 is 115. So if I take 180 and subtract 115, the measure of angle B must be 65 degrees. And since angle D is congruent to it, the measure of angle D must also be 65 degrees. The last thing I briefly want to talk about, we're going to have to use in class tomorrow, I believe, is review for you. When two lines intersect, they make an intersection with 4 angles in it. 1, 2, 3, 4. The ones that are across from each other, such as 2 and 4, or 1 and 3, are called vertical angles. Vertical angles are opposite each other at an intersection of 2 lines. And beyond that, vertical angles are congruent. In this picture, angle 1 is going to have the same measure as angle 3. Angle 2 is going to have the same measure as angle 4. So what that means is, if I'm given one angle at an intersection and there's only 2 lines involved intersecting, I can figure out all the other angles. Let's say that I know that this angle over here is 70 degrees, and these are just 2 lines intersecting. Well, I know the angle that's vertical to it also must be 70 degrees. And then if you'll notice, 70 plus the one adjacent to it, those add up to a straight line, so they must add up to 180 degrees. That means this angle must be 110, and the one vertical to it must also be 110. Okay, so for a final example, we've got an intersection on the bottom of the slide here where there are expressions for 3 of the angles in the picture. And we want to solve for x and find the measure of all angles. So we need to look at this and kind of figure out how some of these are related so we can write an equation. So the easiest way to do that is you might notice that these 2 angles are congruent because they're vertical. So we can just write an equation that sets these equal to each other and solve it. and we get x equals 7. Then to find all the angles, we could just plug the 7 back in for x in all of these expressions and figure out their degree measures. This concludes your video. I hope that you remember some of this so we're ready to work with it in class tomorrow. If you feel like you didn't get it all, you can watch it as many times as you like. Have a wonderful